We're going to work on standard Gibbs free energy and equilibrium calculations. In this example, we are asked to calculate the equilibrium constant at 25 degrees Celsius for the following reaction when the standard Gibbs free energy is negative 75.9 kilojoules per mole, and then we're asked if this reaction is spontaneous. The first thing I want to start off with is my given information. We're asked to solve for K. We do have temperature. We have our standard Gibbs free energy. And we do need the universal gas constant for energy, 8.3145 joules per mole per Kelvin. So I want to take a look at my units before I start, and I see that my delta G is in kilojoules, but my R is in joules. And since this example did not specify units, I'm going to go ahead and convert my kilojoules to joules. Remember, 1 kilojoule is 10 to the third joules. So this equals to negative 75900 joules. I also want to make sure that my temperature is in Kelvin. And since my initial temperature does not have a decimal place, my converted temperature will not have a decimal place. Okay, I've got all my given, and now I'm going to plug into the formula for standard Gibbs free energy. Delta G equals negative RT times the natural log of K. I'm going to plug in my numbers. I'm going to divide by the coefficient on both sides. And I'm going to solve for K by taking the inverse of the natural log. And my K equals 2 times 10 to the 13. So I've solved for the equilibrium constant. Now I want to talk about how K is related to whether this reaction is spontaneous or not. So K is a large number, meaning K is greater than 1. And that means that it favors the products. And if K is greater than 1 and favors the products, that means the reaction is spontaneous, the way it's written. Let's take a look at another example. We're asked to calculate the standard Gibbs free energy at 25 degrees Celsius for the following reaction when the equilibrium constant is 8.2 times 10 to the negative 13, and is the reaction spontaneous? So let's start with our given. This time we're asked to solve for the standard Gibbs free energy. We have our temperature. We have our equilibrium constant. And we have our universal gas constant for energy. Now, before I do anything, I want to make sure I've got the correct units, and my temperature needs to be in Kelvin. And since my initial temperature has no decimal places, my converted temperature will not have decimal places. Next thing I want to do is go ahead and plug into the formula. Delta G equals negative RT natural log of K. I'm going to go ahead and plug in my numbers. And okay, I'm going to plug this into the calculator. I'm going to get delta G equals All right, let's go ahead and relate this to our equilibrium constant, K. K is a small number. The power of negative 13 means it's a small number, less than 1, and the reaction favors the reactants. And if it favors the reactants, the way this reaction is written, this would be considered a non-spontaneous reaction. Good luck and keep practicing.